Having made all of the damper side and the switch side of the rocker, I'm going to move out to start putting stuff on the drive side. So the first thing that's going to go on the output shaft is the collet. So I'm going to put this in the lathe and bore it to 11 millimeters, and that will allow me to mount this slug. That way I can swap it backwards and forwards, turn it around and around, machining the taper and the thread onto this piece while it's mounted on its eventual shaft anyway. So it'll keep it all central. Let's see how we get on with that. Turned up this mandrel, that's 11mm diameter, it's 11mm bore. I've only reamed that, I didn't bore it out, it's a clamp after all. So that can go on there. This can be held on the end somehow. Doesn't really matter about the washers, I can machine them away. Now I can do whatever I want to with that part. So part of this is going to be turning a taper, so you turn a taper in from that direction there. Then once, well, probably I'll turn this down at the end there, get the thread on the end of it, then flip it around and then turn the taper down from that end. The idea of putting it on the mandrel is so that you can just keep flipping it backwards and forwards, still keep it concentric. That's the plan. .015, that'll do. This is the major diameter of the part. Only the extreme end of it needs to be 21mm, the rest of it's going to be tapered down with a 16mm thread on the end. So now I've got to take that down to 16mm at one end. That is going to eat into that washer, which doesn't matter, but that needs an M16 thread on there. So the top slide's set to 5 degrees. It's a 10-degree included angle. I'm only going to do it on the scale on the top slide because I can easily copy that taper later on when I bore out the pulley. So this taper is going to have to come off until I reach that scribe line. That would make this tapered section 19mm long. So I want to make sure I've got enough stroke in it. Stop it there. Take a cut. not a brilliant surface finish. It's actually quite disgusting, but what are you going to do? It's a collet. What I'm attempting to put on here is the fine version of 16mm, so it's 16mm by 1 pitch, and that is what it seems to be. So it's just a matter of cutting it in. I'm going to wind that right out the way and then attempt to take a wire measurement on that. It's a very fine thread for the size of it, but there's no reason why I can't measure it. I was measuring at 16.35. I want 16.313. That's a good job I stopped there, that was close. I'm not going to disturb anything, I'm just going to let that take a bit of a spring cut. It's gone down to 16.24, so that's going to be a bit undersized. I'm not sure what the tolerances are, but as soon as I'm making my own nut to go on it, shouldn't be a problem. Yep. Nice shiny smooth thread. The collet nut I'm not going to make out of the hex bar. I'm just going to make a round nut and then drill 4 holes in the circular nut for a pin spanner. It'll look a lot neater. So the intention is to bore this piece of bar out to 16mm, but leaving 10mm in the end. 10mm blind hole of material. Then I'll swap it around and I'll bore that the other end out to the core size of whatever a 16mm thread is. I don't know, 15.2, something like that. Then cut the internal thread in the opposite end, and then I'll be able to part it off. And the reason I'm using such a large piece of metal is I'm going to be before I finish this part, I'm going to be using this part to hold that part. So I'll thread the two together, and that's when I'll be cutting the slots that are demanded by the drawing. Somehow I've got to keep hold of that part and be able to cut 3 slots in the end of it, and it's not cylindrical anymore, so tricky. But if I thread it and then thread that into the end of there, the threads will hold it, and I'll be able to saw some slots in with it. Once I've sawn the slots, I'll be able to put this back in the lathe, part off the circular nut, and then use that as it's required. Oh yeah. Right, so what I've got there is a 16mm bore with 10mm of material left, and it's that remaining 10mm on that end that I'm going to make the nut out of. So I now need to flip it around and bore this end out to 15.15 or 15.2, whatever the core diameter of the thread is. and when I cut that thread it'll leave me this 16mm bore here just to run the threading tool into, so I can just let the threading tool run all the way into an empty hole or an empty space. Good. Yeah, it's a very snug nut. It's binding up on the male thread, on the end of the male thread where it goes into its undercut, but other than that, yeah, I'm pretty happy with that. Isn't it wonderful what you can do? I can now use this piece to hold that piece while I cut the slots in the collet. Not quite sure what speed to run these things at. Let's see how it goes. Once I get the cut through to the end of the collet where I want to stop, I will then put a table stop on the table so that they're all 3 slots are the same length. So there we go, 3 approximately spaced slots. Of course they're not 90 degrees in the bottom, but they are into a fairly thin area of the collet, which might give them some flex. I can even feel a little bit there just by squeezing it, so maybe it's flexible enough. So I'm not going to faff with those slots anymore apart from deburring them. If it doesn't tighten up properly, then we'll see what we have to do about it, but see if that works. Here's the other bit. So what's going to be seen on the outside of the pulley will be that nut and that bush in the middle. The rest of it won't be seen, it'll be inside the pulley. Now there's absolutely no point trying to indicate this part, it's too irregular. So I'm just using the ball on the stylus to give me a bit of a guide as to whether or not that large diameter is approximately centered. Don't try and use that centre boss as your reference for any of the positioning or holding of this part. That centre hole is in the middle of the major casting, but it's nowhere near the middle of that boss. There's plenty of material on that boss to get it down to size, but don't grab hold of it around the outside and start machining the rest of it off, because everything will be wrong. There's the high point. And there we are. That's zeroed up more than enough for what I'm doing with the casting. Now, despite all of those efforts to get this initial bore centered in the part, the hole is centered with regard to the outer circumference. But when I turn the part over and I look at this crank and counterweight feature, that hole's not in the middle. And it's not that apparent now when it's only an 11mm hole, but when I counterbore this out to 25mm, it's going to become completely obvious. And when I put in the slot feature for the crank pin, it's going to be obvious as well. So all I'm going to do is shift this over. That's about it. So what I'll do now, I'll come down and bore this out with the 12mm end mill. Alright, so this does look all over the place. It's on a new 12mm mandrel now. There's the rear boss, the biggest offender with not being in the middle. But what I am pleased about is that inside diameter on the casting relief, if you like. That does seem to be running visibly concentric. I'm having to do this by hand because I want to wind it out so that the tool cuts in the right way. So if I'm not even taking out a full cut there, I will come back and take a bit more. Make sure I haven't got this entirely wrong. Yeah, 21. See how the collet fits in. There you go. So with a little push and a squeeze, that is about that's a millimetre sticking out, so it's about half more than I'd hoped for. Maybe it's sprung, but it does. I'm probably not going to get that out now. I'll push that in. So that's that board. There we go. There's the nut there. Yeah, I'm quite pleased with that. Not a disaster. Lock that. Start that up and come out the floor. There's my 25mm hole. It's going to accept that nut. So the collet goes in that way, screwed in with this nut that way. Bonza. So this is now mounted on its shaft with the collet, and I'm pretty unimpressed with how well that collet grips the shaft. I've got the nut tightened up as tight as it'll go. I mean, I can't get the pin wrench into it because it's recessed, but it's not a very impressive way of holding on to it. So I'm going to take this form tool here and I'll take down the boss first, get that kind of round so I know what sort of diameter I'm dealing with, and then take this face off. Face off. Took very much at all, is it? So enough of that nonsense. Take it in a bit more. Take it in quite a bit more. Let's just turn round the other way. It's back on the mandrel. Now I'm going to take the whole thing down. That'll be the threaded part of the collet, the nut and the surface of the pulley. That's got to get down to 13 millimeters. It's at nearly 16 now, so there's quite a bit to come off. More mess. So getting ready to cut the slot in the crank wheel, putting a parallel by feel and by eye lined up with that crank slot feature there in the casting, and then running an indicator along that parallel to get the casting pretty much lined up with the table. Okay, so that's going to be good enough centered up for that. It's probably about a thousandth off, but that's good enough for a slot. The pulley's clamped down to the table. This feature is in line with it, so all I've got to do is stroke backwards and forwards. This is a 10mm 2-flute cutter. It's just about long enough to get through. So I'm going to cut the slot 10mm, just plunge in, get the slot to the right length, and then come out side to side to get it the right width, which will leave round the corners in the slot. I'm not really sure if I'm going to bother filing those out, but I probably will. Yeah, 12.04, so slightly over 12, just what it needs to be. After making the pulley, I've just drilled the 2 holes in the main slide bar and put that on the rocker or saddle, whatever you want to call it, on the top. There was a mysterious clearance on the drawing to be machined off the inside of this pulley here. Seemed to have no real purpose at all, but the reason it's there is that the pulley fouls on this slide bar. Now, I didn't want to make a messy looking pulley with another step in it that's just there for basically tolerance stack up or, you know, dimensioning error. So a fouling condition like this really shouldn't exist, but it is what it is. I'm not going to machine anything to relieve these parts or this fouling, but what I've always intended to do is to make up a thrust washer to go on the boss of the pulley there. So there's nothing here to stop that pulley from rubbing on the trunnion bar, whatever you want to call it, the rocker. I would like to have some sort of thrust control on this shaft as it runs. There isn't anything in the design. The only thing that's going to stop that shaft from floating one side to another is the general load on the crank pins and the sliders and things like that, and the conrod, or the key on the shaft butting up against the bronze bushes at these areas here. I don't want to be using a key as a thrust control device. So I'm going to put a thrust washer in here, and I'll make 2 of them because I'm going to put a thrust washer at this end as well, and then leave this shaft sticking out that long, so no need to cut it any shorter, and make a collar to fit over the end of the shaft, secure it with a little grub screw, and then we'll have a thrust washer this end, a thrust washer that end, and we'll be able to set up or control whatever inflow this contraption is going to have. It might stop it rocking around a bit and clattering and banging as it wears in and wears out. So no relief to be machined off any of these parts. I'm going to measure this gap with feeler gauges here to give me some idea on at least how thick that thrust washer needs to be, then make one a little bit thicker. Sorry, make 2.